Hi viewers, this is Sri Ramulu. So before watching this video, please subscribe my channel. My channel is s.s space physics. Okay friends, let me enter into the today's topic. So today's topic is change of entropy of a perfect gas. So for perfect gas, how does the entropy changes? So that is we have to calculate here. Consider 1 mole of perfect gas at a pressure P, temperature T, and occupying volume V, right? So here we have to consider only 1 mole of perfect gas we have to consider. What is a perfect gas? Perfect gas is also called as real gas. Okay, so sorry, not real gas, ideal gas. So ideal gas equation is what? Its equation is we write PV is equals to nRT actually. Okay, so but here what I'm taking only 1 mole of gas, so that is why n value becomes 1. Then we write PV is equals to RT. Okay, now if dq be the amount of heat given to the gas, the increase in entropy is given by, okay, so if we supply the dq amount of heat energy to the gas, then what happens? So its entropy can be changed as dq is ds is equals to dq by t. So what is this? This is actually second law of thermodynamic formula. So that relates, that has a relation between entropy, heat, and temperature. Okay, so it is from second law of thermodynamics. Next, by first law of thermodynamics. So from the first law of thermodynamics, what is first law? dq is equals to du plus dw. It is the first law, where du is increase in internal energy of the gas and dw is external work done. Okay, so dq is equals to cv dt plus pdv. So this can be written as dw, also can be written as pdv. Okay, so now sometime we write dw and sometime we write it is pdv. And how does it has come? So in the place of du, so actually is what? cv is equals to du by dt, and if you bring this dt this side, it becomes cv dt is equals to du. So that is why in the place of du, it is written as cv dt. Next, now what I am doing, I'm going to replace this dq. How? From this one. So what is this? We can write it is a dq is equals to tds. So here we write tds. Here actually we have to write t ds, but this t brought this side, so that is why it becomes division. Here also division. Okay, so here one step is the decrease, please understand. Now to express the entropy in terms of volume and temperature, eliminate p from the equation 1. From perfect gas equation, for 1 mole is the pv is equals to rt. What I am doing, I want, so it is actual formula, right? So what is that? dq is equals to cv dt by t plus p dv by t. Okay, so it is actual formula. Now what I am doing, to express entropy in terms of, so I want to write entropy in terms of volume and temperature. So if I want to write the entropy equation in terms of volume and temperature, then what I have to do, I should replace p, I should remove the p. So for this what I will use, I use which one? It is ideal gas equation or perfect gas equation I use. So for this pv is equals to rt, I will write p is equals to rt by v. So now we can easily replace this one. In this place we can write it is rt by v. So that if I see here, in the place of that I have written here, same it is taken this side. Okay, and now ds is equals to cv dt by t plus rt by v. Now t gets cancelled here. So what do you get? We get r into dv by dv by we get. So this is the equation. Now see, it is in terms of v and a t only, no other words. So these are actually, it is a constant, it is not, it is constant. You cannot, we don't have any here, any p value we don't have. So that is why it is in terms of t and a v. Okay, now we have to integrate this equation, right? So for entropy, yes initial to yes final we have to integrate. For temperature, t initial to t final we have to integrate. Similarly for volume also, v initial to v final we have to integrate. Now see, after integrating this ds, we write simply, it is like this. Okay friends, so after integration we write s final minus s initial. If you want to integrate it, and you can understand easily. Okay, so by integrating this one, where to where we have to integrate, yes initial to yes final. So if you integrate, then you can get like this equation, this equation you can get. Okay friends, so like this you can get. Similarly if here also you have to integrate. Okay, so here t initial to t final, t initial to t final. Okay, and here also v initial to v final. So after integrating, see here, before integrating, it is a t is there and it is a dt. So that means what, t, it's a differentiation above is there. So when it's a differentiation present in a numerator, then we write simply log f of x. Log, we use log. Why? So f of, it is f of x and it is f dash of x. That means its differentiation is presenting here. So we write, if it is f of x, then we write simply log t only we write. Okay, and by applying the limit t initial to t final here, t initial to t final, then what you get, you get, see here this side. Now see, come this side. So before that, let me read it. The change in entropy is final minus S initial when the gas changes from initial volume to initial. So gas changes from which, from initial to final state. So initial is volume is a V initial, T initial temperature, and a final volume is V final, and the temperature is T final, can be obtained by. So like this we can obtain. This is, now see, integrated this side initial to final, so applied here. And now it is not only belongs to, so it is actually we should not write a t initial. Why? Because not only t, it has also we have. So by integrating inside, then it is a t we have, so t initial, here volume is there, so volume initial. Okay, so once again common is taken, the constant quantity is taken outside, and here also taken outside, and one more time is written, and it is a log f of x formula. So I think everybody know about the log f of x. So what is the log f of x, right? F dash of x, f dash of x by f of x, if any function present like this. Okay, so it is a dash, means it's a differentiation present above. If you are integrating it with respect to dx, with respect to x, then what? So its formula is what, if when it's a differential present above, then we write simply it is as log of f of x we write. Okay, log of f of x. So that means only this one we are here we are right. So same thing, you see, it is f of x, so here it is written only here this is, and here also same thing like this. So that is why it is written here. And so now we have to apply the limits, and the limits is what, initial to final. So first to final term we have to substitute minus initial. Similarly here same thing. Okay, so like this. Now see, log a minus log b forms are there. So we can write log a by b, log a minus log b is equals to what, log a by b. So that is why log a by b formula is used here for this and for this also. So finally we got this one. So this is the expression in terms of volume and temperature. Next, to express the entropy in terms of temperature and pressure. So now temperature T and P, we have to express it in terms of T and P, and eliminate V or dV. So from equation 3, where is this? So this from equation 3, where is this? See, this is 1. Actually not from 3, it is equation 1 actually. Okay, sorry, it is equation 1. So this formula, it is a basic formula. So this one we have to use everywhere. Sorry, this one only. So okay friends, so this is a major formula. Which one? Not this is what, this one is major formula, equation 2. So it is not a 3, it is equation 2. So from 2, what we have to eliminate? We have to eliminate v and dv, both we have to eliminate. Okay, why? Because we want in terms of t and p. So here we don't have p, so replace it with p. How can we replace? We have to take a ideal gas equation. Okay, and differentiate on either side. So it is uv method, pdv plus vdp, uv method, and it is r constant, and t is simply dt only. From this so bring this by keeping this is this side, and bring all these are this side, then we write rdt by rdt minus vdp by p we get. So from this we get like this, and this dv value substitute in the equation 1, it is not 1. In equation 2 we have to substitute. Okay, so it is wrong, it is not 1, equation 2 only. So this is equation 2, right? So equation 2, dx is equals to cv dt by t plus p dv by t, right? Now in this place, so replace this one with what? With this one. Then what we get? So like this we get. Okay, right. So t 1 by t is written this side only, and now see p gets cancelled, only t remains, and separate the t, this by this and this by this we write. Okay, so it is like this by this and this by this written. And now here what we have, and here dt by t we have. So this side, and before that what we have to do? V by t is there, so again use the pv is equals to nrt, pv is equals to rt. By using this formula, what we can change? We can replace what? This one, we can replace v by t. How? So see, t bring this side and p bring this side, so it becomes like this only. So v by t can be replaced by r by p, so r by p is replaced. Now it is a pp, so it is easily integrable. It is also integrable easily, it is also integrable easily. But before that, what we have to do? In this place, in this place what I am doing, I am taking this one, cp minus cv is equals to r. So already this equation we know, cp minus cv is always r, is equals to r. And now multiply this side inside, then what happens? This one gets cancelled, and the remaining are these two things only. Now see, it is in terms of t and p only. So what we have taken here? So we have to express in terms of temperature and pressure only. So finally we got. Now integrating this one, so this integration is simply this common always comes this one only, and for this here t initial to t final, and for this p initial to p final. Okay, like this. Now same thing, it is also comes log, and difference, after taking difference again, if you take a log a minus log b, how we have done here, in the same manner I have done here. So please read carefully. Okay, so we get after this doing this one we can get. Okay, so it is in terms of t and f. Next, final one, to express the entropy in terms of pressure and volume, then what we have to do? We have to eliminate t from which equation? From second equation, not one equation. So we know that pv is equals to rt, and from this t is equals to pv by r. So and differentiating, so differentiate it dt, and it is uv, it is constant. Uv method is same thing. Okay, it is uv method, and r no need to derive it. Why? Because it is constant. Now substitute this value in the equation 2. Okay, so in the place of dt by, in the place of dt I have substituted. Okay, in the place of, so equation 2 is c once again, this one, dt by t, in the place of dt I have substituted, right, in the place of dt. So now, and again now separate these two things. So and before that we have to write it here, rt is there, in the place of rt we can write pv. now PV. So separate now. By separating, these two gets cancelled, and here also volumes gets cancelled. All right. Here CV, here CV is there, and R by V, R by V. So if you bring this is this side, and T comes this side, P by T will get. R by V becomes P by T. Or here what I have done here, P is multiplied and divided, right? P is multiplied and divided. So PR and PV. In the place of PV, we write it is what? So it is up in the place of PV. No need to write again. Okay, see here. So in the place of RT, PV is written and separated. It is like this. P by T. P by T is what? From this equation, bring T this side, P by T, and it will bring this side, R by V. So we got R by V. Okay. And now, so it is mistaken. This one actually no. So only it is R by V only. Now what we have to do here? Both are same. See, dv by v, dv by v. We can take common outside. So cv plus r, dv by d plus cv d. It is like this. It is written this side. Okay. Now, so what is actually we know the cp minus cv is equals to what? R we know. Cp minus cv is equals to R we know. So from that cv plus r is cp. So simply we can replace this one by cp and is cv. Now integrate on either side. Okay. So after integrating, what he gets? So like this. So we get, and by doing this here certain simplification, so finally we get this equation like this. So it is now in terms of v and p only. So from any one of any one, the three expression 3 4 5 6 can be, it is not he, can be used for calculating change of entropy for perfect gas. Okay. So change of entropy can be calculated by using above three equations only. So okay friends, so don't forget watching this video till the end.